Hi all. So this is Indira from Byte Academy. So today I'm going to talk about blockchain. So this webinar topic is Introduction to Blockchain. Okay, the technology behind Bitcoin. So many of you might have heard about Bitcoin. Okay, the cryptocurrency. So there are many cryptocurrency, but the famous and the first one is Bitcoin. So this introduction to blockchain is completely a non-technical perspective. So I have prepared it in completely a non-technical perspective. So let's understand what it is. That is what is the purpose. So what is this word blockchain means? So let's start. Yeah. So let's see a real life scenario. So suppose you're in a grocery store and you're scanning the QR code to buy your favorite coffee. Okay, so let's see what happened. Let's say we can, while you are buying your favorite coffee, okay, you'll be able to see the details, every detail of that coffee. You can view the details of where the coffee beans grew. Okay, it might be coming from a faraway village. Okay, that's grown over there. So you will be able to see where it is grown, how it is cleaned, processed, and then roasted. And what if you can trace the supply and the distribution to know the means of transport and how long it took to reach the store near you and now in your hand. Okay, so that much transparency is there. Then what will happen? It will be very interesting, right? So then you will trust that because everything is transparent. So all the records, they are not hiding anything. Everything is transparent to everybody. So they keep the records like that. So if anybody is trying to do something, okay, in the process of cleaning this, everybody knows everything. So there are less chances to uh, less chances to occur such a mistake or something. So things are transparent to everybody. You will trust it more. Okay. Is there any technology that can help record information at each step and make that information available to everyone transparently, as well as secure that information? Is there anything like that? Yes, that is what is blockchain technology. Okay, so it is not restricted to any one field like cryptocurrency or banking. Okay, it's not like that. So wherever you have information to keep, wherever you have transactions, wherever you have some events happening, and you wanted to keep a record of those events, which should be transparent to everybody who is participating in the end-to-end process, and all these transactions should be secure in the sense nobody should be able to do any malpractice in between. Nobody will be should be able to change any transaction details. So if you need such a record keeping system, so that is what is blockchain basically. So blockchain technology can be applied in any field and many fields. Okay, not only the cryptocurrency thing. So let's start blockchain. Let's get an introduction to blockchain. So welcome all of you to the world of blockchain. So you can understand it like this. So what is it? Everything, whatever work or transaction or job or anything, any field, they need some software, right? So blockchain is also a software which has a particular algorithm which helps you, algorithm in the sense a procedure which helps you or everybody who is part of that whole end-to-end thing, which helps you to see all the things, like which makes it transparent to all the participants and which makes it secure. So that kind of thing in the internet. So many softwares, something will work on your um, personal computer, okay, like stand alone. Something will work in the internet. So Any technology, anything we are using, your record keeping, you use your computer and internet and share things in internet, right? So something like that, that is what is blockchain. So basically you can say blockchain is a record keeping tool which allows the records to be secure and which allows the record to be transparent to all. And it's very difficult to break or change the information in a blockchain. So that is made sure using some cryptographic algorithm. So we are not going to cryptographic basics and all. So something like that you might have heard about encryption and all. Okay, you're sending something from here to here, something on the internet, some text, some messages, so it'll be encrypted and sent. So that sense you might have heard about cryptography. So you are encrypting your message, so you're converting it into some other form and sending. So at that end, that person only knows the way, or he will have some key to decrypt this. Okay, like put it back to the normal readable message. The other end person only will have. In between, nobody will be able to change it or view it or access it. Okay, so that kind of technology is called as cryptography. So in the blockchain technology, we we are using cryptographic algorithm to make sure the security of this transaction. So let's say cryptocurrency. So you were all using online banks, online account, online transactions you are doing. So if somebody is able to change your transaction, it's a big thing in banking, right? And someone needs to be monitored. So let's say if I am trying to make a 50,000 transaction and I keep on trying, I forgot my password and all. Okay, you'll get a call in within some seconds from the bank person asking like, you only tried to do that transaction, that transfer, because they don't know someone else is trying on your behalf, or not on your behalf, without the knowledge of you. So that is what is a banking, online banking is happening. So some person needs to be there to monitor all the transactions. So in the case of blockchain, that is not required. There's no need of a like central authority. So in between the transaction of you and your friend, who is monitoring that? The bank is monitoring that. That's why if you keep on trying, you might have forgotten your password and you keep on trying. Okay, you'll not get anything. Like the third time, if you try and it'll get blocked. That is one security mechanism applied over there. And if you are trying and it didn't happen, then you'll get a call and bank person, they are checking with you directly, like you are only trying to do this, right? Because they don't want any malpractice in between. So the blockchain algorithm do it by itself. Okay, no central authority needs to be there to monitor. So it is a self managing algorithm which keeps all the transactions secure and transparent to everybody. So that is called as blockchain. So the cryptocurrency, the very first cryptocurrency is Bitcoin. The underlying technology of Bitcoin is blockchain. So you can define blockchain something like this. Blockchain is an immutable, distributed, decentralized, and peer-to-peer ledger. What do you mean by ledger? You can say ledger means a record keeping tool replicated across multiple nodes connected in a network. Nodes in the sense the computers, like mostly generally it will be computers connected in a network, making it possible to record data about any event or transaction as it happens. And it consists of, so the representation, visual representation of blockchain, you might have seen it consists of blocks in a chain used to record as digital assets using a secure algorithm. So what is blockchain? Blockchain is something like this. We are using cryptographic algorithm to make it secure. So let's see each terms in this. Immutable. What do you mean by immutable? Yeah. Blockchain is an immutable. So what do you mean by immutable? Immutable means non-changeable. Any transaction, once it happens, cannot be changed. And blockchain, in a blockchain. So there's no malpractice. There can't be, no one can access the data in between. So blockchain is immutable. It is distributed. Why we say that it is distributed? There is no central authority to store it. Sorry, to monitor it. Okay. There's nothing like that. So let's say something like, okay. So I think you'll be able to see my white screen. So let's say a different kind of networks are there. So these are all computers. Okay, let's say it's you are a star. It is a star network. We'll say like this is a star network, computer network. Okay, so this is the central computer. This is the central computer, and it will be connected like this. Okay, it will be connected like this. So this computer controls everything, the central authority, the central computer. Okay. So if this two computers wanted to communicate between them, it is the path is always through the central computer. Like you are transacting with the payment gateway and all, it's always through the bank. Your transaction is always through the bank. If you wanted to communicate, this computer want to communicate with this, the path is always through the central computer. So let's say this is a computer central machine, or somebody hacks and it lost all the information. Okay, it lost all the information. The whole system is gone. Okay, the whole system is gone. So, but in case of blockchain technology is on peer-to-peer network. So there is no central authority or central machine. If there everything is on a central machine, if that machine is hacked and you lost the information from there, it is lost for permanent loss it is. So this is something like a peer-to-peer network. The computers, the nodes, this is called as a node in the blockchain. Okay, so anybody can communicate with anybody. Okay, now there is no central authority watching. So this is interconnected. Like, so blockchain technology works always on a peer-to-peer network. So, and if you apply the blockchain technology on top of a peer-to-peer network, how it is, the important thing of blockchain is like it is transparent. So you know every information, every transaction, what others do, everything on the every transaction, everybody knows. So that is what is. That's why we are calling it as transparent. So blockchain is an immutable, distributed in the sense the information is shared with everyone in the process or in the peer-to-peer network. Decentralized, why it is called as decentralized? There is no central authority. All are bosses. And peer-to-peer ledger. Why do you call peer-to-peer? It's on a peer-to-peer computer network. Ledger means record keeping tool. So it is an immutable, distributed, decentralized peer-to-peer record keeping tool replicated across multiple nodes connected in a network. A node is a computer in a peer-to-peer network where blockchain technology is applied. So making it possible to record data about any event or transaction and making it very secure using a secure algorithm or a cryptographic algorithm. So that is what is blockchain. So you can conclude it like blockchain technology is a type of distributed ledger technology. It's an accounting system where the ledger means record of transactions are distributed among a network of computers. So as it is core, blockchain is a record keeping tool, you can say, which is secure and transparent. So the visualization of blockchain, you'll always see some blocks and chain. Okay. So what do you mean by that block and chain? So let's say the term blockchain refers to the fact that it is a chain of blocks. Okay. So why it is called as a chain of block? What do you mean by that block in a blockchain? What do you mean by that chain? So it is a chain because everything is recorded in a chronological order. Chronological order means that is sequential. So it has an order. This is the first block. This is the second block. So first block in the sense there's a block of information, block of transactions, a bunch of transactions. A block means a bunch of transactions in the blockchain. And blocks because the transactions are added to the chain in groups rather than individually. So every transaction, it's not added one by one to the blockchain. It is added as a bundle into the blockchain. So one block represents a bundle of transaction, a bunch of transaction, a block of transaction. Okay. So that is what is the block. It is connected with a chain, blockchain. Okay. What do you mean by this chain? Why it is connected to a chain? It is represented like that. Why? Because every block is connected. Every block is related, or there is an order of these blocks. So the first block of information, it is dependent. So from the first block of information, you need some that using the cryptographic algorithm to to construct the next block, you need some unique information from the first block. So it will extract that using a cryptographic algorithm. That is what is called as a hash. So you need to know that hash to create the next block. So this block is connected to this block, and the second block, the hash from the second block is required to create the third block. So you mean that every block is connected. That is why we are using a chain. That's why we are using the representation of blocks connected using a chain. Each block records a number of transactions similar to a page in a record keeping book. Yeah, that is one good example. So you can visualize it as a book. Okay. So each block records a number of transactions similar to a page in a record keeping book. So let's say we have a record keeping book. The number of pages, every pages in a book is you can say like it's a block. If you are saying every page is a block, the amount of transactions on a block varies from blockchain to blockchain. Okay, so you have multiple blocks. The blocks are connected. In a book, a pages are connected, right? Why? There is a chronological order. This is the first page. This is the second page. Whatever ends at the second page, it continues on the third page. So the pages are connected. There is an order. There are page numbers. So you can say like the pages are blocks and it is connected through the page numbers. So comparison of blockchain. The amount of transactions on a block varies from blockchain to blockchain. So there are different kinds of blockchain where the block sizes varies. So you can say like there are different kinds of books like of different size. So there are small books, there are big books. So the small book is a one kind of blockchain where the page size is less. One page can contain less information and all the pages are connected through page number. You can say there is a big book in size. There is a bigger size book. So every block is one page. So the size of information which can one page can contain in that book is different, right? And the pages are blocks and it is connected through page number. Something like that, a big book and a small book, different blockchains. The different blockchains used in different technology, different areas can be different. What is different? The size of the block is different. Like one block can contain varying information. The number of information contains will vary. The amount of transactions on a block varies from blockchain to blockchain. So let's say, for example, each blockchain on Bitcoin. So Bitcoin technology, the underlying technology is blockchain. So let's say it's a Bitcoin blockchain. Each block on the Bitcoin blockchain holds up to 1 megabyte, 1 MB of information, 1 MB of transactions it can store. So Bitcoin blockchains block size is 1 MB. Some other area, they are using the blockchain as underlying technology. The block size may vary. And the transactions are recorded in the form of hashes. So that is what is strings of numbers and letters. So transactions are recorded in the form of hash. So you can say like the hash of each transaction is generated to include information from the current and past transaction. So one transaction to other transaction, all the transactions in the blockchain are connected. You can say you need some information from the last transaction to create the next transaction. Or you can say like you need some information which is unique, which you should know to create the next block. You need that information from the first block to create the second block. Or you can say you need some information, that is what is called as a hash. You need that hash to create your second transaction. And you need the hash from the second transaction to create the third transaction. So all transactions are connected. Okay, if you make any changes in any transaction, the all of the hashes will change. Okay, so the system will come to know, and that is not possible. That's not possible. You cannot guess that hash and you cannot change that hash. You cannot change any transaction. So that is what is behind the security of a blockchain system. So these transactions are recorded, yeah, hashes. So we'll said about hash. So this creates a chain effect where the order of hashes cannot be changed. You cannot change the order of records. If you're trying to change one thing, everybody will have the copy of all the transactions. Every computer in the blockchain network, P2P network, will have a copy of all the transactions. If you make trying to make change in one transaction, there's nothing like one hash will change means everything will change, everything will come to know. The system will come to know and you cannot do that. Okay, so this creates a chain effect where the order of hashes cannot be changed. As a result, transactions are immutable. That means non-changeable once they have been added. That is why we are saying like, so this is done using cryptographic algorithms or security algorithms. Okay, this made practical using that. So that's why we are saying blockchain is safe or secure. So your transactions in a blockchain is secure and it will manage it, algorithm will manage it by itself. So let's say in the future, if the blockchain technology is applied on the online banking, the bank can be called as a self-banking. So there's no one, no, there's no need of a human resource to sit and track the transaction, sit and observe like who is doing what, anybody is doing any malpractice on any account, not anything like that. That's not required at all. It will be self-managed by this blockchain algorithm. Okay, so you can call it as a self-banking. So if this is applied in any area, the company is planning to apply blockchain technology on any of their areas, they will need very, very less like human resource. That is one advantage. So let's say what are nodes? So I'd already told you. So this is a peer-to-peer network. Okay, these are computers on a peer-to-peer network. So this is blockchain like our transactions. So it is saved as a bunch of transactions is one block is connected to another block with the hash, so it is related. You need to know something of the previous block and to create the next block, so like that it has a chronological order. So all these people, they are doing some transactions, these two or anybody. Okay, so all this, the copy of the blockchain will be having every computer in the network, or this P2P network, every computer, that is called as a node. So a node in a blockchain can be any electronic device that is part of a P2P network and maintain its own copy of the blockchain. So this computer has its own copy of blockchain. Every computer in the P2P network or every node in the blockchain will have a copy of the blockchain. Copy of the blockchain means copy of the transaction details. So let's say it will be like this. Okay, the blocks connected with chain. So it is previous hash. So something like this, this is the hash. So It needs this hash to create this bunch of transactions. If this so and it is formed its own hash from the previous hash. Okay. So these two blocks are related. That's why it is we are showing a chain between them. So the whole thing is called as blockchain, blocks and chain. This is creating its own hash. This is required to create the next block. It will create its own hash. If you change something like this hash is changed, then everything is changed, right? So that's very difficult to do. Like it's literally not possible to break it, or that means it is not possible to like any malpractice. You cannot change any transaction in a blockchain network. You can't do any malpractice. What makes blockchain technology unique? So yeah, these qualities makes blockchain technology unique. So decentralized, what do you mean by decentralized? Because blockchains are managed by a network of nodes rather than a central authority. So if you have a central authority, okay, if someone hacks that machine, every information will be lost, and that made it not secure. That is making that system less secure. So there is nothing like that in blockchain. Everybody will have every information. So they are fully decentralized. This prevents any one entity from having any control over the network. Transparent, that we have discussed, transactions on a blockchain are constantly being recorded and stored on the blockchain across the nodes. So everybody knows everything. So that means all the participants can view all the transactions on the network in real time. That makes it transparent. Immutable means non-changeable. So the blockchains are designed to enable permanent record keeping so that the data cannot be altered after being added. So this makes it an extremely stable and reliable record keeping system. Secure, yeah, it's hard to change or destroy blockchains because of its distributed nature, and security is ensured using cryptographic algorithm. Distributed, that means the data is shared. So let's say database and blockchain both keeps records. So but database is centralized. You will have a server, database server. Okay, every information is actually stored there. You're accessing it from your machine. You're accessing actually that server and take the machine and made changes actually in the server. So everything is stored in the server. So you can say like database is centralized and a single point of failure. If your database server fails, everything is gone, lost. So in contrast, the blockchain is decentralized and distributed on multiple nodes across the network. So every node in the blockchain network collectively takes part in the consensus algorithm using proof of work here. So that is what is the name of algorithm. Use the security algorithm or the algorithm used in blockchain. So we are not going into the detail of consensus algorithm, proof of work and all. Peer-to-peer, yes, it's not a centralized network, it's using peer-to-peer. So all this makes blockchain unique. So let's know something about Bitcoin. So many people think that Bitcoin is same as blockchain. They use the term Bitcoin in replacement as blockchain. Okay, Bitcoin means blockchain like that. So it's not like that. Bitcoin is a cryptocurrency. The underlying technology of Bitcoin is blockchain. So it is like blockchain. Bitcoin is just one application area of blockchain. Bitcoin is just one application where the underlying technology is blockchain. So how it that kind of misconception comes in means the blockchain technology is first used in Bitcoin. So let's see some history. So in 2019, one person named Satoshi Nakamoto, he introduced Bitcoin. to the world. So his goal was to create a peer-to-peer payment network that would remove the need for a third party to verify this transaction. So in the cryptocurrency or a Bitcoin, there is no one there is no one, no bank, and nobody is there to monitor your transaction. Okay, so that is what is Bitcoin. So his idea was about Bitcoin. So for Bitcoin, he needs something like this. So before Bitcoin, the only way people could exchange money digitally was through a bank only. Okay, so there is no bank in Bitcoin cryptocurrency, the exchange or online service. So that was like that. These all examples of the third parties that control our information, money, and transaction record. But Bitcoin, there is no third party. So he thinks he thought he when he started thinking about the idea Bitcoin. Okay, what he did to solve his problems. To solve this problem, Satoshi Nakamoto described the use of blocks connected in a chain that was chronological and permanent. So this allowed people to. So he developed the um, blockchain technology a bit, and it became the form it is there today. So he developed that, and he used that Bitcoin blockchain technology in the Bitcoin. So the very first Bitcoin application is blockchain. So to solve this problem, Santoshi describes the use of blocks connected in a chain that was chronological and permanent. So this allowed people to exchange money, knowing their transactions were secure and irreversible. So once you are done, you cannot change, anybody can change. So this became what we know as blockchain technology nowadays. So people thinks that you cannot apply it anywhere other than cryptocurrency, but it is not like that. You can apply blockchain technology in many other fields other than cryptocurrency like Bitcoin. So Bitcoin is the first cryptocurrency, first application of blockchain. So where can we apply blockchain? You can apply it in many other areas. So let's say food safety. So currently Walmart is working with IBM for enhanced tracking and traceability of food products, resulting in better food safety. So all this procedure, they need a technology like blockchain, which is self-managing. No human interference is required. So in the area of food safety, they are using blockchain. And money transfer from anywhere to anywhere on the globe. So that is what is cryptocurrency without any third party monitoring you, like Bitcoin. So that is an area of blockchain application. Blockchain can be applied. Regulatory compliance and audit. So blockchain is very secure, immutable, and making any alteration to transactions are very difficult. So that can be made use of the regulatory compliance and audit area. So you can use blockchain technology there also. Supply chain, yeah. So we were talking about the coffee shop example at first. So it is something like supply chain, like one Singapore-based company created a permissioned blockchain-based supply chain to monitor products as they move along from the manufacturer to the store shelf. From the manufacturer to the store shelf, everything needs to be recorded. All the transaction to where it is moved, what they did on top of that, what they added, what they did, it is moved to one place to another place, and finally it reaches to the store next to you. So all the transactions should be recorded, which should be safe and secure. No one should be able to alter, no malpractice. And all these things are self-managed using a software. There's nobody needs to be monitored. So that is a big thing, right? So you can use it in supply chain also. There are many more applications. We can use blockchain technology, which makes it like self managing machines. Okay, self banking, a bank which is working, no one is there. So like as a whole bank is one software like blockchain technology. Yeah, you can take an account, you can transact money, nothing, no human intervention, everything is managed by blockchain algorithm or software. So you can use it in many other places. Yeah, let's watch a video. Let's see. and wind up this presentation.
When you vote, have you ever wondered whether your ballot is actually counted? If you meet someone online, how do you know they're who they say they are?
I started from the first. You can see the description, the captions in English.
When you vote, have you ever wondered whether your ballot is actually counted? If you meet someone online, how do you know they're who they say they are? When you buy coffee that's labeled fair trade, what makes you so certain of its origin? To be sure, really sure about any of those questions, you'd need a system where records could be stored, facts could be verified by anyone, and security is guaranteed. That way, no one could cheat the system by editing records because everyone using the system would be watching. Systems like this are on the horizon, and the software that powers them is called a blockchain. Blockchains store information across a network of personal computers, making them not just decentralized, but distributed. This means no central company or person owns the system, yet everyone can use it and help run it. This is important because it means it's difficult for any one person to take down the network or corrupt it. The people who run the system use their computer to hold bundles of records submitted by others, known as blocks, in a chronological chain. The blockchain uses a form of math called cryptography to ensure that records can't be counterfeited or changed by anyone else. You've probably heard of the blockchain's first killer app, a form of digital cash called Bitcoin that you can send to anyone, even a complete stranger. Bitcoin is different from credit cards, PayPal, or other ways to send money because there isn't a bank or financial middleman involved. Instead, people from all over the world help move the digital money by validating others' Bitcoin transactions with their personal computers, earning a small fee in the process. Bitcoin uses the blockchain by tracking records of ownership over this digital cash, so only one person can be the owner at a time and the cash can't be spent twice, like counterfeit money in the physical world can. But Bitcoin is just the beginning for blockchains. In the future, blockchains that manage and verify online data could enable us to launch companies.
Yeah, I'm not sure you're able to see my screen. Yeah, I think you are. So let's finish this off. Let's start from the first.
When you vote, have you ever wondered whether your ballot is actually counted? If you meet someone online, how do you know they're who they say they are? When you buy coffee that's labeled fair trade, what makes you so certain of its origin? To be sure, really sure about any of those questions, you'd need a system where records could be stored, facts could be verified by anyone, and security is guaranteed. That way, no one could cheat the system by editing records because everyone using the system would be watching. Systems like this are on the horizon, and the software that powers them is called a blockchain. Blockchains store information across a network of personal computers, making them not just decentralized, but distributed. This means no central company or person owns the system, yet everyone can use it and help run it. This is important because it means it's difficult for any one person to take down the network or corrupt it. The people who run the system use their computer to hold bundles of records submitted by others, known as blocks, in a chronological chain. The blockchain uses a form of math called cryptography to ensure that records can't be counterfeited or changed by anyone else. You've probably heard of the blockchain's first killer app, a form of digital cash called Bitcoin that you can send to anyone, even a complete stranger. Bitcoin is different from credit cards, PayPal, or other ways to send money because there isn't a bank or financial middleman involved. Instead, people from all over the world help move the digital money by validating others' Bitcoin transactions with their personal computers, earning a small fee in the process. Bitcoin uses the blockchain by tracking records of ownership over this digital cash, so only one person can be the owner at a time and the cash can't be spent twice, like counterfeit money in the physical world can. But Bitcoin is just the beginning for blockchains. In the future, blockchains that manage and verify online data could enable us to launch companies that are entirely run by algorithms, making self-driving cars safer, help us protect our online identities, and even track the billions of devices on the Internet of Things. These innovations will change our lives forever, and it's all just beginning. To learn more about the urgent future of the blockchain, please visit iftf.org/blockchainfutureslab.
Yeah, so that's it for today. So thank you all for joining. So please join me on Discord to continue the discussion if you want. So we have a community over there in the Discord. So you need to install Discord in your Discord in your laptop or mobile phone. Okay. And you need to click on a link to join our community Nestria. So where if you do that, so this is what is our community Nestria. Okay. So let me invite you all. Let's see. Invite people. So this link, if I'm copying and pasting it, I think Deepti is also there in the call. You can copy that to in the chat. I'll copy this in the command later. So once you installed this Discord app in your laptop or mobile, you can click on this link to join this community. So this is our Nestria community. So see, we have many channels. So you can go here in the left part, start here, join a topic. So these are the topics. So we have a channel for Python, JavaScript. So this is a community where people discuss over things technical. So let's say we have a blockchain channel here also. So if anybody of you wants to continue discussion, you join this blockchain launch and blockchain resources where we can continue the discussion. Okay, my name is Indira. So my Discord, once you install Discord, you can ping me. And this ID, you if you search Indira #2935, if you search for me, you'll get, and you can directly ping me also over Discord. So thanks all for joining. Please don't forget to subscribe us Byte Academy on YouTube. Have a great day. Bye.